Here we go, we're recording. So what these are called the double angle identities for sine and cosine. And you might say, why would I ever want to use those? And they're useful if you want to find sines or cosines of exact values of sines and cosines of angles that I'm missing something. This doesn't look like your sheet, does it? Oh, but this goes, did I have these ones on here? Oh yeah, I have this. Okay, so if you want to find sines and cosines of angles that are exact, but like this, tan of negative 15 and sine of 5 pi over 12, they're useful for finding those things if you have like half of the angle or double the angle. And I'll show you how those work. And these come out of, where do they come from? They come from, like this one in particular, it's derived from a formula for alpha plus beta. So if I did, I have to change something. This will let me right on here. Okay, so if I put into the formula that cosine of 2 theta, you don't have to write this down. I just kind of want to show you where this comes from. Cosine of 2 theta is equal to cosine of theta plus theta, right? Yes? And so you could write that using the cosine formula as cosine theta minus sine theta. If I plugged into that angle addition formula. And then I can combine these two things. And what I have is I could write this as 2 cosine theta, right? And I could write this as 2 sine. No, I couldn't. I could write this as, I'm looking at this one. I could write this as cosine squared theta. And I could write this as sine squared theta. And so I could rewrite cosine of 2 theta as cosine squared minus sine squared. So basically, just to show you, they're using these angle addition formulas to derive these other formulas. And that's where they come from. But it's easier just to memorize the formulas. All right? So, okay, I got the big eraser. So, let's see how these apply to various situations. So, for instance, this one right here, I'm going to grab a picture of it and make it all kind of bigger here. I want to do some of these. All right. So, I know what I did wrong. First one. So I want to do something like this. That's better. So say I want to find an angle theta between pi and pi over 2. Where is pi? Where is theta? Which quadrant? Between pi over 2 and pi. Quadrant 2. So you draw a little picture over here in quadrant 2 that looks kind of like this. Alright? And just like we've been doing, the sine of this angle that's theta right there. And you want sine of 2 theta. And so the sine is 3 over 5. So you call that side 3, this side 5, and what would this side be? -4. Very good, -4. And then you just plug in to all of these formulas. So sine of 2 theta, the only formula that they have for sine of 2 theta is this one. Okay? So that looks like 2 times sine of theta, which is 3/5, which they give you, times cosine theta, which is -4/5. And then you multiply everything on the top together, you get 6 times -4, which is -24, and you multiply everything on the bottom together, and that's 25. So what is this telling you? It's telling you you have some angle whose sine is positive 3/5, okay? And it's in the second quadrant. They want to know what the sine of an angle that would be twice that big would be. So it kind of makes sense because an angle, the ratio of this is 3 to 5. Twice that angle would probably be in the fourth quadrant, and that's why it would be negative. You understand? Because sine is negative in the fourth quadrant. All right, so that's kind of how you do this. Cosine of 2 theta, I would use, it doesn't matter which formula I use, but since they give me sine of theta is 3/5, there's 3 different formulas, and the way they convert these is by using that 1 minus sine squared is equal to cosine squared, and 1 minus cosine squared equals sine squared, so that's how they change these around. But the cosine of 2 theta, since they give us the 3/5, all you have to do is plug that into this formula right here, and you get 1 minus 2 times 3/5 squared, and then you just do it. So it's 1 minus 2 times, what's 3/5 squared? 9/25, right? You got to square both the top and the bottom. So that's 1 minus 18/25, which is 7/25. And that's the answer. Cosine of 2 theta is positive 7/25. Which kind of makes sense because if I determine that this is probably an angle in the second quadrant, then the cosine is positive over here in the fourth quadrant. Tan of 2 theta, use this formula, and the way that works is 2 times tan of theta is what? Negative 3/4 plus over 1 minus 1 minus negative 3/4 squared, right? Negative 3/4 squared. You did that right, didn't I? 1 minus tan is negative 3. So on the top, I get, let's go down a little bit here. On the top, I get negative 6/4. And the bottom, I get 1 minus 9/16, because it's minus, and when you square this, it turns into a plus. So you get, that's negative 3/2, reducing that top. And this is 1 minus 9/16 is positive, right? Positive what? 7/16, that's a third fraction to it. And then you could cancel things, or you could flip and multiply. That's what I did, since some of you guys will get confused if I don't. That's 16/7. And then I can cross out this, and this, turn that into an 8, and this into a 1. And I get negative 24/7. Get it? Is that all right? Easy? Okay, so that's how you apply those formulas. Next one. What's next? How do I do this? So this one here is just kind of like number 68 on that last problem set. So with this one, whoops, we didn't get the whole thing. I hate when that happens. Let's try that again. Let's try that again. There we go. So what this says is you want to find the cosine of 2 times some angle whose cosine is 4/5. That's what that says. So in other words, you have an angle. Where is cosine positive 4/5? Which quadrant? The first quadrant. So you draw a picture in the first quadrant. And this is your angle theta right here, and its cosine is 4/5, which means that this is 3. Okay? So you want to find the cosine of 2 theta, and since they already gave me the cosine of that angle, I might as well use that other formula, which was, now I forget, 2 cosine squared minus 1? Is that what it was? No, 2 cosine squared minus 1. So I'm going to use that formula. Cosine 2 theta is 2 cos squared theta minus 1. And they already give, so you don't really even have to draw the picture for this one. So cosine of 2 theta is equal to 2 times 4/5, because they told me that is cosine. So this means cosine of theta is 4/5, right? Or I could just look at the picture, 4/5 minus 1 squared minus 1, which gives you 2 times 16/25 minus 1, which is 32/25 minus 1, which is, that's 25/25, right? So the answer is 7/25. And the remarkable thing is that the answer always has a 7 in it. Not really. Just coincidence. Yeah. All right. So next thing, you guys need a joke, don't you? I can't tell you a joke right now.
I think we do.
Okay.
I think we do.
Bathroom. You sure? Okay. Wait a minute. You're gonna miss my joke? Okay. I don't remember any for right now. Why do elephants paint their toenails red? You don't know that? Why? Yes, so they can hide in cherry trees.
Wait, can you repeat that?
Why do elephants paint their toenails red? So they can hide in cherry trees.
Can you explain how it makes sense?
Have you ever seen an elephant in a cherry tree?
No.
It's like an anti-joke. What's
I still don't get it.
Okay.
what is green and it's really confusing?
I don't know.
Green ones are green.
Okay, let's move on. So now we're going to talk about the half angle formulas, and I never paused that. These are the half angle formulas, okay? And this is important. These things have both a plus sign and a minus sign, and depending on which quadrant theta or alpha over 2 is in, you choose plus or minus. So for example, down here with tangent of negative 15 degrees, negative 15 degrees is in which quadrant? Fourth quadrant. Okay, so with the tangent half angle formula, if you're using this formula right here, is tangent negative or positive in the fourth quadrant? Negative or positive? Negative, okay? So in that case, you would use the bottom half or the negative part of this formula, okay? So over here, you have to decide which quadrant you're in when you do this. Okay, so let me do the sine one first, because that's kind of will come first, and then we'll do the tangent one. So partial, I'm going to take this whole picture because I can never remember the formulas. I will give you these formulas when you take a test, on the test, so you don't have to remember them. But the double angle formulas, I think I'm going to have to make you memorize. All right, so the half angle formulas, let's try this. Sine of 5 pi over 12. So what you want to do is call this, what you want to do is kind of say, let 5 pi over 12 equal theta over 2. That would mean that theta would be what? If I doubled that, what would I have? That's right, 10 pi over 12, which is equal to, when I reduce it, 5 pi over 6. Okay? So when you use the half angle formulas, this angle that you're looking for the exact value of, it's half of something that you know the exact value. So they're kind of problems that are set up for you. So theta is going to be 5 pi over 6. So, and 5 pi over 6, if you draw a little picture, it's an angle in the second quadrant. But theta over 2 is an angle in which quadrant? Theta over 2 is an angle. Where's 5 pi over 12? Which quadrant? That's in the first quadrant. because 6 pi over 12 would be the same as pi over 2. So this over here would be theta over 2. They call it alpha over 2, but we'll call it theta over 2. So then, because sine is positive in the first quadrant, you don't go by this, you go by this, okay? Use the positive half of this formula. And then, so, except I plug in 5 pi over 6. So what I'm going to do, I'm going to do plus the square roots of 1 minus cosine of 5 pi over 6, that whole thing over 2. You get what I did? So you plug in theta into the formula, but to figure out which sign you're going to use, the plus or the minus, you're using the original angle, the theta over 2. Okay, because this is, if this is theta over 2, then this is theta. So now you simplify things, which can take a few steps. 1 minus, who knows what the cosine of 5 pi over 6 is? It's an angle in the second quadrant. Very good. Who said that? Logan and Justin. Very good. So it's minus root of 3 over 2. But it's still that whole thing over 2. And I should actually extend this square root thing so it's over the whole thing. That's a 3 there, in case you can't read it. Okay, so I'm going to change this into a plus sign. So it's 1 plus root of 3 over 2. And then I'm going to simplify, which comes out to be 2 plus root of 3, that whole thing over 2, that whole thing over 2 over 1, which is the same as, okay, 2 plus root of 3 over 4. Any questions so far? What I did with the algebra? Where did I get 2 plus root of 3? I multiplied 1 by 2 over 2. So I could have a common denominator up here, okay? So this is 2 plus root of 3 over 2, that whole thing over 2, which is really over 1, right? Okay? And then I can flip and multiply, and when I do that I get a 4 on the bottom, and then what you do is take this 4 out of the square root sign, because you're allowed to do that. So this becomes 2 plus square root of 3 square root of that over 2. And this would be your final nicely simplified answer. And that's kind of weird because you have a square root of something in a square root, which is kind of a weird answer, but that's what it is. Yes, ma'am? This? That's a 2 over a 1. 2 over 1. I'm sorry. Yes. What was the point of finding here? When I went, what do you mean? No, I didn't. Okay, because now I can pull that square root out. All right. What? What's wrong? Wake up. Yeah. So let's do this one. Inverse tangent 15. So let's use this formula, and we'll take a picture of it again because this one is kind of more fun. Place, capture, new page. Hey, John, what are you doing? Huh? Okay, so with this one, if this is theta over 2 or alpha over 2, what's theta? No, this is different one. What's 2 times negative 15? Negative 30. Okay, so if theta over 2 equals negative 15, then theta equals negative 30, and this is in degrees, which is nice for you. And then I can use either of these formulas. Well, the nice thing about this formula is that you don't have to worry about choosing the plus or the minus. The nice thing about this formula is that all you have to know is the cosine. You don't need to know the cosine and the sine. I don't know, I kind of like these formulas. So let's use this formula without having to worry about the plus and the minus. Good? And you get tangent of negative 15 is equal to 1 minus, what's the cosine of negative 30? You guys remember what that is? Cosine negative 30, remember that's down here? Yep, and that's positive root of 3 over 2. That's a root of 3 over 2. Can you tell that's what that is? And on the bottom, I get sine of negative 30. Nice, Olivia. Negative 1/2, or Katie, whoever said that. Very good. Okay? So now again, I'm going to find the common denominator. Watch. So this is 2 over 2, so on the top I get 2 minus root of 3 over 2 over 1/2. And did you know you're allowed to do this? Boom, boom. You're allowed to do that. So what you're left with is 2 minus square root of 3, which is a nice, easy answer, right? And so then, I happen to know, since I was in high school a long time ago.
Yeah, it's not negative.
Oh, yep. Sorry, negative 1/2. Negative 1/2. So what happens is this is negative and this is positive, right? So it's minus 2 plus root of 3. And since I was in high school a long time ago, and they made me remember that the square root of 3 is about 1.732, I can subtract this from this in my head, and I get approximately 2 negative 0.2, what would that be, 268 or something like that? Because they made me memorize that when I was in high school. They square root of 3 and square root of 2 really come up too much. Yes?
So to simplify that, multiply it by 2 over 2.
To simplify,
From the first part to the second part, we have 2.
yes, I multiplied this by 2 over 2.
So
Which
multiply
gives
by
me
2 over 2.
this by 2 over 2. 1 by 2 over 2. Which gives me 2 minus root. So I have a common denominator and then I can combine. And so if you did happen to go to your calculator, watch this, boys and girls. If I did happen to go to my calculator, oh wait, alright. And I were to plug in the tangent of negative 15 degrees, I would get negative 0.2679, which is about what I said it was right here. Right? So as you can see, right, negative 2 points. I did all that without ever having to touch a calculator, which is kind of cool. And that's why they teach you to find exact values. Because way back when, they used to make you memorize these things and you could approximate what the tangent of negative 15 was without a calculator. As far as could I do this one without a calculator? 2 plus square root of 3 over 2 square root of, that'd be kind of hard. All right, next. You ready for this one? I don't know how to do this. But I'm just going to do one of them anyway. I'm just going to guess. All right, so if you see one of these, and you will, I'm sorry, but you will, what you want to do is, okay, theta is, cosine of alpha is negative 3/5. Alpha is between pi and 3 pi over 2. But what you want to do is find alpha over 2. So if alpha is between 3 pi over 2 and pi, then alpha over 2 is going to be between what? Divide both of these by 2. Pi over 2 and 3 pi over 4, which puts you in which quadrant? Which pi over 2 is here, right? And 3 pi over 4 is here. So you're going to be somewhere here in the second quadrant, right? And in these second quadrants, sign is negative or positive. Sign is negative or positive? Positive, right? And so if I'm using this formula for the cosine or excuse me, the sine of alpha over 2, I'm going to use the plus in front of that, because alpha over 2 is in the second quadrant. You understand that? Okay. Even though this, between pi and 3 pi over 2, that's over here in the third quadrant. But you're looking for alpha over 2, which would be in the second quadrant. So you have to divide this domain by 2 to get which quadrant alpha over 2, which tells you whether you choose the plus half or the minus half. Okay? So I'm going to choose the plus one in this case, and then it's 1 minus cosine or plus cosine? 1 minus cosine. I always forget these formulas, so that's why I'm not going to make you remember them. So they already tell you that cosine of alpha, right, over sine alpha? Is that right? Sine. Oh, over 2, I'm sorry. Over 2, I'm taking it at the end. Okay? So that's equal to positively square root of 1 minus, well, they tell you that the cosine of alpha is 3/5, so it's minus 3/5, which makes plus 3/5. Over there, that whole thing over 2. Okay? Let's see if you could simplify this fraction for me. What's that equal to? Square root of 5 plus 3, right? 5 plus 3 over 5, which is 8/5 over 2, which is the same as, that's like over 1, right? So that's the same as square root of 8/10, which if you're really I would just leave it like that. If you want to be really clever, okay, this is equal to 2 root 2 over root of 10, right? Because that's 2 root 2, and you can break up square roots like that. And then if you want to take it a step further, you could rationalize the denominator by multiplying by root of 10 over root of 10, which gives you 2 root of 20 over 10. You can take it a step further, which is 2 root of 4 times root of 5, so it's 2 times 2 times root of 5 over 10, which is equal to 2 root of 5 over 5. Okay?
Or you could just divide it.
Wouldn't it be simple? Yes! Sorry. Okay, very nice. That would be easier to go like that. Right? Which is equal to 4/5, right? And the square root of 4 is 2 over root of 5. And then when you rationalize that, you get that. Okay, either way, this was worse. Okay, so I'm done. Sorry to teach you so long for all of this 28 minutes. But